Here is our last problem. In the figure, ABCD is a rectangle and EFGH is a parallelogram. Using the measurements given in the figure, what is the length D of the segment that is perpendicular to HE and FG? So here's the hint. In this problem, we are trying to find the area of something in two different ways. And this is something we've learned in our geometry problem so far, is when you're trying to find one of the parameters of a shape, try to see if you can find the area of that shape first. And the way you're going to find the area is to use another set of parameters. As you can see, D is the height of this parallelogram here, because it is perpendicular. So in order to find D, which is one of the parameters, the height of the parallelogram, we need to find the area and the base of the parallelogram first. Right? So we know that D times the base is equal to the area of the parallelogram. Let's try to see if we can find the base. Well, D has to be perpendicular to EH and GF, so what is EH and or GF? We have a right triangle here, 3 and 4, so we know that the hypotenuse must be 5. That means that this segment here is 5. So we know that its base, the base 2D, is 5. So we're trying to find the area. Now, how do we find the area of this shape here, this quadrilateral? Now, this is also kind of working backwards, right? Because we, already identified what we need to find in order to solve the problem, and that is the area. Now the problem is, how do we find the area of this shaded in region? Well, when solving the area of complex shapes or shapes that are kind of irregular, like we don't know immediately what its parameters are, we can try to take away the pieces that's surrounding it. For example, ABCD is a large rectangle, so we could just take away all these regions here in order to find the area of EFGH. So, let's first find the area of the big rectangle, and that is 10 times 8. That is 80. So that is the area of the large rectangle. And now let's try to find these shaded in regions. Well, 5 times 6 times 1/2 times 2 plus 3 times 4 times 1/2 times 2 is just equal to 30 plus 12. So this is 42. So we have to take 42 away from 80, giving us 38. So we know that the area is now 38. So what is D? So D is equal to 38 over 5, and that gives us 7.6. So our final answer is 7.6. And that is how you solve for the area of a complex geometry problem by finding the area in two different ways.